Welcome to our channel. We are so glad you found your way here. Let us help you fall asleep. Let's begin with Petrichor, the science behind the smell of rain. Messing, take a slow, deep breath in and release it. Let the weight of the day fade away as we embark on an unhurried, atmospheric journey through the wonders of the cosmos. Your mind is quiet, the universe is vast, and we are ready to explore. This phenomenon, known as Petrichor, refers to the distinct, earthy scent that emerges when rain falls on dry soil. The term itself is derived from the Greek words petra, meaning stone, and ichor, the fluid that flows in the veins of the gods in Greek mythology. This etymology reflects the connection between the earth and the divine, suggesting an inherent beauty in the natural world. Petrichor is primarily the result of a combination of plant oils, bacterial byproducts, and ozone. When raindrops hit the soil, they release these compounds into the air, creating the recognizable scent. The oils are secreted by certain plants during dry periods, helping to protect their seeds and roots. Bacteria within the soil also play a crucial role, particularly a species called actinobacteria, which produces a compound known as geosmin. This substance is largely responsible for the earthy aroma associated with rain. The intensity of petrichor can vary based on several factors, including the type of soil, vegetation present, and the amount of rainfall. In arid regions, the scent can be particularly pronounced as the dryness allows for greater concentration of the volatile compounds. This localized experience highlights the intricate relationship between the environment and the sensory experiences it generates. Descriptions of the smell of rain date back to ancient civilizations, where the phenomenon was often imbued with significance. Early texts from Mesopotamia, for instance, reflect a profound reverence for rain, associating its arrival with fertility and renewal. This region, characterized by arid conditions, viewed the scent as a harbinger of life, a promise of sustenance for the land. The Greeks, too, documented their observations in poetic forms, capturing the essence of rain's fragrance as a divine blessing. Philosophers such as Aristotle noted the invigorating quality of this scent, attributing it to the interaction of rain with the earth. Their accounts reveal a deep understanding of the natural world, although they lacked the scientific terminology that would later emerge. As cultures evolved, so did the language surrounding this sensory experience. In the Middle Ages, literature began to describe the odor with more nuance, reflecting a growing curiosity about the natural phenomena. Writers portrayed rain as a source of inspiration, one that invigorated both the landscape and the human spirit. The modern term petrichor, coined in the 20th century, encapsulates these historical perspectives, linking them to the scientific principles governing the release of aromatic compounds from the soil. Such a term signifies not only the scent itself, but also the enduring connection between humanity and the atmospheric conditions that shape our environment. Geosmin plays a pivotal role in the phenomenon of petrichor. It is a compound produced by soil-dwelling microorganisms, particularly actinobacteria. During the decomposition of organic matter, when rainfall occurs, the impact of water droplets displaces geosmin from the soil, releasing it into the air. This compound is renowned for its earthy aroma, often described as reminiscent of fresh, damp earth. In this region, geosmin's presence becomes significantly pronounced after a dry spell. When it accumulates in the soil, the sudden arrival of rain brings a wave of olfactory sensations, linking the moisture with the distinct scent of the earth. The human nose is finely attuned to detect geosmin at incredibly low concentrations, often as low as 5 parts per trillion. which speaks to its biological importance. This connection allows individuals to instinctively recognize the onset of rain through smell alone. The release of geosmin can also invoke memories and emotions tied to the natural world, reinforcing the relationship between sensory experiences and environmental conditions. In addition to its sensory effects, geosmin may serve ecological functions, including attracting various organisms that contribute to soil health. Its presence is a reminder of the complex interplay between biological processes and atmospheric phenomena, illustrating the multifaceted nature of this enduring connection. Geosmin, a compound primarily responsible for the earthy aroma following rainfall, possesses a distinctive molecular structure comprising a combination of carbon and hydrogen atoms. It exhibits a bicyclic arrangement, specifically a bicycloheptane framework. This configuration contributes to its stability and volatility, enabling the compound to evaporate into the air. Upon release, a geosmin rapidly disperses, permeating the environment and eliciting a sensory response that is universally recognizable. The properties of geosmin extend beyond mere fragrance. Its synthesis occurs predominantly in soil-dwelling microorganisms, particularly actinobacteria. Upon cell lysis, a geosmin is released into the surrounding soil, where it interacts with atmospheric conditions. The compound is highly soluble in organic solvents, yet exhibits limited solubility in water. This characteristic allows it to remain concentrated in soil, providing a natural reservoir until precipitation events facilitate its escape into the atmosphere. Rain biliso, antifucainture. The olfactory receptors identify geosmin, triggering a memory response that often evokes feelings of nostalgia or tranquility. The concentration of this compound in the air varies, influenced by factors such as humidity, temperature, and soil composition. In regions with rich biodiversity, the presence of geosmin can serve as an ecological indicator, reflecting the health of terrestrial ecosystems and the intricate relationships within them. Soil microorganisms play a crucial role in the production of geosmin. Various bacteria, particularly those from the genera Streptomyces and Actinobacteria, are significant contributors to this process. These organisms thrive in moist environments, where organic matter is abundant. As they break down organic materials, they produce volatile compounds, including geosmin. The metabolic pathways involved in this biosynthesis highlight the complex interactions between microorganisms and their environment. Fungi also participate in the generation of geosmin, though their contributions are less understood. Mycelial networks form expansive systems beneath the surface, facilitating nutrient uptake and decomposition. These fungal communities contribute to the overall aroma of the soil, enriching the sensory experience of rainfall. When rainwater infiltrates the soil, it triggers the release of these compounds into the air, creating the distinct scent that is often associated with the onset of rain. These interactions are not limited to organic decay. Soil microorganisms actively influence nutrient cycling, promoting the availability of essential elements for plant growth. The intricate balance of these organisms sustains the ecological health of the region. Rainfall acts as a catalyst, awakening dormant microbial populations and enhancing the production of geosmin, further underscoring the interconnectedness of life within these ecosystems. The scent of rain thus serves as a reminder of the unseen processes at work beneath the surface. Soil type significantly influences the aroma released during rainfall. Various terrains contribute unique characteristics to this olfactory experience. Clay-rich soils, for instance, hold moisture more effectively than sandy environments. When rain falls upon these dense aggregates, it interacts with organic materials and bacteria present, resulting in a distinct earthy fragrance. This particular scent, often described as robust and rich, emerges from the complex interplay of microbial activity and chemical reactions occurring in the soil. And in contrast, sandy soils, which allow for rapid drainage, tend to yield a lighter, crisper scent. The quick absorption of water means less interaction with organic matter. This environment often produces a more subdued fragrance, characterized by subtle hints of salinity, especially near coastal regions. The differences in terrain thus dictate not only the strength of the aroma, but also its nuanced qualities. Additionally, regions with high organic content, such as forests or wetlands, offer a markedly different olfactory profile. The decomposition of plant matter contributes to a more complex and layered scent, often described as sweet or pungent. In urban areas, the interaction of rain with man-made surfaces can lead to a unique amalgamation of smells, including those from asphalt and concrete. Each type of soil and environment shapes the experience of Petrichor, highlighting the intricate relationship between ecosystem and scent. Rainfall intensity plays a crucial role in the manifestation of Petrichor. Light rain often produces a subtler scent, where the moisture barely penetrates the surface, allowing only the faintest traces of volatile compounds to escape. In contrast, heavy precipitation leads to a more pronounced olfactory experience. The force of raindrops striking the ground creates a greater release of oils and enzymes from soil particles, amplifying the aromatic compounds that characterize this phenomenon. Mode: moderate to intense rainfall saturates the ground, increasing the efficiency of gas exchanges between the soil and the atmosphere. The impact of each droplet dislodges microscopic particles, stirring them from their resting places. This dynamic release of oils, primarily originating from plants and soil bacteria, contributes to the robust aroma associated with a downpour. The specific chemical compounds responsible for Petrichor, including geosmin and various terpenes, become more concentrated under such conditions. Meteorological factors influence this relationship as well. Humidity levels and temperature dictate how readily these compounds vaporize into the air. High humidity enhances the ability of the atmosphere to retain these scents, allowing them to linger longer after rainfall ceases. As the water evaporates, it carries with it the essence of the landscape, creating a moment of connection between the earth and the sky. Each rain event reshapes the olfactory landscape, reinforcing the bond between environment and sensory experience. Atmospheric conditions such as temperature and humidity play a crucial role in the release and perception of this distinctive scent. When the air is saturated with moisture, humidity increases, enhancing the capacity for volatile compounds to linger and disperse. This heightened moisture content allows aerosols to form, carrying the earthy essence of Petrichor more effectively to the senses. Optimal temperatures also contribute significantly to the olfactory experience. Warmth fosters the evaporation of essential oils released from soil and vegetation, amplifying their presence in the air. When combined with rising humidity, it creates a perfect environment for these compounds to flourish. The interplay of warmth and moisture transforms the landscape, drawing forth the hidden aromas that lay dormant, awaiting activation. In contrast, cooler temperatures may inhibit the volatilization of these compounds, diminishing the potency of the scent. The smell of rain is often less pronounced in arid climates, where low humidity prevents the rich experience associated with wetter environments. Each unique combination of temperature and humidity shapes the intensity and character of Petrichor, making it a variable sensory experience across different regions. The intricate balance of these atmospheric conditions continues to evoke a connection between the natural world and human perception, grounding individuals in the moment and offering a reminder of nature's profound impact on the senses. The release of geosmin into the atmosphere plays a crucial role in the olfactory experience associated with rain. Soil-dwelling microorganisms, particularly actinobacteria, synthesize this compound during their metabolic processes. When moisture saturates the soil, the mechanical agitation of raindrops dislodges geosmin, allowing it to volatilize. This process transforms the compound from a liquid state into a gaseous form, elevating aromatic molecules into the surrounding air. The humidity present during rainfall enhances this volatilization, ensuring that geosmin disperses effectively. As the rainwater interacts with the soil, it creates microbubbles, which burst at the surface, releasing it into the atmosphere. The concentration of geosmin varies depending on factors such as soil composition, moisture levels, and the specific microbial community present. This variability contributes to the distinct scents experienced in different environments. Geosmin's presence in the air can trigger strong emotional responses, often evoking memories of past experiences tied to rain and the earth. The human nose is remarkably sensitive to this compound, detecting it at concentrations as low as 5 parts per trillion. This acute sensitivity underscores the deep-rooted connection between humans and the natural world, illustrating how even the faintest sense can influence mood and memory, reminding us of the intricate interplay between life and the environment. The presence of plant oils significantly contributes to the aroma of petrichor. These volatile compounds are released from various vegetation during dry conditions, accumulating in the soil and on surfaces. Once precipitation begins, water droplets displace these oils, allowing them to evaporate into the atmosphere. This process creates the distinct scent associated with the onset of rain, a phenomenon that can evoke a sense of nostalgia or tranquility. Different species of plants produce unique oils, each imparting subtle variations to the overall fragrance. For instance, the oils from grasses and certain trees release specific terpenes, which are responsible for the characteristic earthy notes of petrichor. These compounds interact with the moisture in the air, forming a complex bouquet that can vary across regions and ecosystems. The timing of this release is also crucial. It can occur after prolonged dry spells when the soil and vegetation are particularly arid. Such conditions enhance the intensity of the aroma, making the rainfall experience even more pronounced. This interplay between soil, plant life, of Dorktra, and atmospheric conditions creates a dynamic environment where the olfactory landscape is in constant flux. The delicate balance of these elements not only enriches the sensory experience but also plays a role in ecological interactions, influencing pollinator behavior and the broader ecosystem's health. The impact of various plants on the chemical composition of petrichor is significant, with different species producing distinct volatile compounds. These substances can vary based on factors such as the plant's genetic makeup, the specific environment in which it grows, and its physiological condition. Some flora, like certain grasses, release compounds known as geosmin, which are responsible for the earthy scent often associated with fresh rain. This compound is produced by soil-dwelling microorganisms and can be heightened by specific plants during periods of drought. In contrast, aromatic plants such as rosemary or mint contribute their own unique fragrances to the air, adding layers of complexity to the overall scent profile. The release of oils and other aromatic compounds can vary with the seasons, leading to fluctuations in the olfactory experience. These variations are influenced by factors such as temperature, humidity, and light exposure. The interactions between these diverse plant emissions and the atmospheric conditions following rainfall create a unique olfactory moment, evoking different responses in both humans and animals. The presence of these chemical signatures can trigger memories, emotional responses, and even affect behavior, illustrating how intertwined the sensory experience of Petrichor is with the surrounding ecosystem. This intricate web of plant chemistry and atmospheric interaction underscores the importance of biodiversity in maintaining ecological health. The interaction between raindrops and soil initiates a series of complex processes that contribute to the release of petrichor. Upon contact, water droplets create a temporary disturbance in the surface layer. The force of impact generates a fine aerosol mist, releasing volatile compounds trapped within the soil. These compounds originate from a variety of sources, including decaying organic matter and microbial activity, which thrive in the damp environment. Soil particles play a crucial role in this phenomenon. They serve as a reservoir for oils and organic compounds, which become more bioavailable when saturated. As raindrops penetrate the ground, they disrupt the delicate balance of moisture and air, allowing these compounds to escape into the atmosphere. This release is not uniform. Various soil types yield differing concentrations of these volatile substances. The chemical constituents involved in this release include geosmin and other aromatic compounds. Geosmin, a sesquiterpene produced by soil-dwelling microbes, is particularly significant due to its earthy scent. These volatile organic compounds ascend or carried by updrafts, creating a distinctive aroma that signals the arrival of rain. This process exemplifies the intricate relationship between the atmosphere and the soil, revealing how even subtle changes in environmental conditions can influence sensory experiences. The role of microbial activity in this context is significant, particularly regarding seasonal variations in soil chemistry. Microorganisms play a pivotal role in nutrient cycling, breaking down organic matter and releasing essential compounds. During warmer months, heightened microbial activity occurs, leading to increased decomposition rates. This results in a surge of volatile organic compounds, contributing to the characteristic scent associated with rain. In contrast, colder seasons see a decline in microbial populations, leading to a different chemical composition in the soil. This variability means that the scent emitted before rainfall can differ significantly between seasons. In spring, for instance, a rich array of organic materials breaks down, producing a complex blend of compounds. These compounds include geosmin, which imparts an earthy aroma, and plant oils that also contribute to the olfactory experience. Temperature and moisture levels influence these microbial communities, dictating their activity and the resultant chemical transformations. When rain falls, it disrupts the soil surface, releasing these compounds into the atmosphere. The interplay between moisture and temperature serves as a catalyst, triggering microbial responses that directly affect the concentration of scent molecules. This intricate balance showcases the dynamic nature of ecosystems and highlights the critical input of microbial life in shaping atmospheric phenomena. Each season brings its own unique olfactory signature, a subtle reminder of the interconnectedness of life and environment. Changes in climate can significantly influence the production of geosmin, the compound responsible for the earthy aroma associated with rain. Variations in temperature and precipitation patterns affect soil moisture levels, impacting the microbial communities that produce this essential compound. Elevated temperatures can accelerate microbial metabolism, leading to increased emissions of geosmin during rainfall events. This region, characterized by its diverse ecosystems, may experience shifts in vegetation and soil composition due to changing climatic conditions. Such transformations can alter the dynamics of soil bacteria, further influencing the biogenic release of geosmin, A decline in certain species could disrupt the balance, leading to variations in the intensity and quality of the petrichor scent. A kingstinning sickest meterikonon Petrichor. In urban environments, the heat island effect exacerbates the situation, potentially increasing the frequency of intense rainfall. Rapid runoff may wash away the organic materials necessary for geosmin production, diminishing the experience of petrichor in heavily developed areas. So, as ecosystems adapt, the relationship between plant life and microbial activity will evolve, potentially leading to new forms of geosmin production. Understanding these changes is crucial, as they not only affect the sensory experience of rainfall, but also hint at broader ecological shifts resulting from climate change. The fading company of familiar scents may be replaced by new olfactory experiences, reflecting a changing world. But the association between petrichor and positive memories often stems from deeply rooted psychological responses. This phenomenon occurs as the scent between petrichor and positive memories often stems from deeply rooted psychological responses. This phenomenon occurs as the scent, released during rainfall, becomes intertwined with various life experiences. Its presence during significant moments, such as childhood play or quiet reflections, ingrains this aroma within the subconscious. The brain, capable of forming connections between sensory stimuli and emotional states, registers these encounters. Through the release of geosmin, a compound produced by soil-dwelling bacteria, this region becomes a reservoir for nostalgia. When rain falls, welling bacteria. This region becomes a reservoir for nostalgia. When rain falls, the airborne particles engage the olfactory receptors, triggering memories that may evoke comfort and tranquility. These experiences can manifest in feelings of safety, warmth, of joy. Some studies suggest that the anticipation of rainfall itself can induce a sense of calm and relief, particularly in arid environments. This expectation builds an emotional landscape where the act of rain conjures memories of renewal and growth. The connection between petrichor and happiness is further reinforced by its role in nature's cycles, symbolizing rebirth and the replenishment of resources. These relationships highlight a broader understanding of how environmental factors influence human psychology. The interplay of scent, memory, and emotion serves as a reminder of the intricate bond between our surroundings and our inner experiences. This connection emphasizes the importance of nature in shaping personal narratives. Cultural interpretations of this phenomenon reveal a profound appreciation for its sensory impact. Petrichor has inspired countless literary works, evoking feelings of nostalgia and renewal. Writers often utilize the scent to symbolize transformation, a bridge between the past and the present. This olfactory cue serves as a reminder of fleeting moments, capturing the essence of memory in texts ranging from poetry to prose. Such literary references highlight the emotive power of rain and its ability to elicit deep-seated emotions. Artists, too, have found inspiration in this aroma. Visual representations often seek to encapsulate the ethereal quality accompanying rain-soaked landscapes. Paintings and photographs convey the subdued colors and textures that emerge following a rainfall. This region, saturated with moisture, takes on a fresh vibrancy, a visual metaphor for hope and renewal. The interplay between earth and sky is represented through different mediums, inviting contemplation of nature's cycle. In various cultures, the scent of rain holds spiritual significance. Rituals often celebrate the arrival of rain, marking it as a sacred time of rebirth and nourishment. Folklore frequently intertwines with this phenomenon, weaving narratives that reflect humanity's relationship with the environment. Through these artistic expressions, the essence of Petrichor transcends the sensory realm, embedding itself within the cultural psyche. The subtle aroma of Petrichor plays a significant role within ecosystems, acting as an attractant for various forms of life. Following rainfall, certain chemical compounds released from soil and vegetation influence the behavior of pollinators and other animals. These compounds, primarily geosmin and other volatile organic substances, create a recognizable scent that signifies moisture. In this region, bees and butterflies are drawn to the fresh scent, associating it with the availability of resources. The heightened activity of these pollinators promotes plant reproduction, ensuring a robust and diverse flora. Additionally, the scent serves as a signal for herbivores, indicating the presence of fresh, nutrient-rich vegetation. Animals rely on their acute sense of smell to navigate their environment. This olfactory cue becomes especially crucial in arid landscapes where water is scarce. The scent of Petrichor can draw them toward areas where they may find sustenance and hydration. Microorganisms within the soil benefit as well, with increased moisture levels encouraging their activity. This interplay between scent, moisture, and life forms fosters a thriving ecosystem. The cycle of rain, Petrichor, and the subsequent biological responses exemplifies the intricate relationships that sustain life, revealing the interconnectedness of organisms and their environment. The scent that emerges following rainfall has been linked to various health benefits, particularly in the realms of mood and emotional well-being. This phenomenon, often associated with feelings of calm and renewal, can elicit positive psychological responses. The environment becomes infused with a distinctive aroma, primarily from compounds released by soil-dwelling bacteria and plant oils. These entities contribute to the olfactory experience, creating a natural ambience that many find uplifting. Research indicates that exposure to this scent can reduce stress levels and enhance overall mood. The inhalation of these volatile organic compounds may stimulate the brain's release of neurotransmitters, which play a pivotal role in regulating emotions. In this way, the olfactory cues provided by Petrichor contribute to a sense of tranquility, promoting relaxation and mental clarity. Environmental factors surrounding the occurrence of rain further amplify this effect. The cooling air, combined with the myriad of scents from wet soil and vegetation, creates an atmosphere conducive to reflection and introspection. This region transforms into a sanctuary where the sensory experience can indeed foster a greater appreciation for nature and encourage mindfulness. Such profound interactions between sensory perceptions and emotional states underscore the significance of rain and its accompanying sense in daily life. The impact of Petrichor extends beyond mere enjoyment, offering tangible benefits for mental and emotional health. Sensory perception plays a crucial role in the detection of Petrichor. When rain falls, it releases specific compounds into the air, notably geosmin, a byproduct of soil-dwelling bacteria. This substance, along with oils secreted by plants during dry periods, contributes to the unique scent experienced after rainfall. The olfactory receptors in the human nose identify these compounds, sending signals to the brain that interpret the aroma. The brain processes these signals in the olfactory bulb, where various scent molecules are distinguished. This region of the brain is closely linked to emotional memory, explaining the nostalgic feelings often associated with Petrichor. An individual may recall memories of childhood, specific locations, or significant life events upon encountering this scent. Variations in perception exist among individuals, influenced by genetics and past experiences. Some may find the smell invigorating, while others might associate it with dampness and decay. This diversity in response reflects the complex interplay between biology and environment. The response to petrichor can trigger physiological effects as well. It may lead to a decrease in stress levels, promoting relaxation and enhanced mood. Such reactions illustrate the deep connection between sensory experiences and emotional states, highlighting the profound impact of this natural phenomenon on human well-being. The resorption of geosmin from soil requires precise methodologies that reflect the intricacies of the Earth's surface. Various techniques have been developed to efficiently extract this compound, each aiming to preserve its delicate nature. Solid-phase microextraction stands out as a favored method, utilizing a coated fiber to absorb volatile compounds while minimizing contamination. This technique allows for the direct sampling of soil, capturing the essence of the Earth's organic composition. The use of liquid-liquid extraction is another approach, where soil samples are combined with solvents to separate geosmin from other organic materials. This process relies on the careful choice of solvents to ensure that the desired molecules are efficiently dissolved. Following extraction, gas chromatography often assists in analyzing the composition of the samples, identifying the presence and concentration of geosmin with remarkable accuracy. Other methods, such as headspace analysis, allow for the examination of volatile compounds emitted from soil samples during controlled conditions. This technique emphasizes the dynamic release of geosmin and its interaction with moisture, crucial for understanding its role in odor perception. The soil, rich in microbial activity, becomes a complex matrix from which geosmin emerges, connecting the realms of chemistry and sensory experience. These scientific endeavors illustrate the meticulous efforts to unravel the underlying processes that give rise to the aromatic essence of rainfall. Temperature significantly influences the perception of smells, particularly in regard to the aroma released during rainfall. Higher temperatures tend to enhance the volatility of scent compounds, allowing them to evaporate more readily. This increased evaporation results in a more pronounced olfactory experience, as the molecules linger in the air longer and travel further, reaching the receptors in the nose with greater intensity. Warm conditions create an environment where the moisture content in the air rises, contributing to the overall scent profile. The warmth enhances the release of geosmin from soil organisms, which plays a crucial role in the characteristic earthy fragrance associated with rain. This compound, along with various oils secreted by plants, becomes more accessible to the atmosphere, enriching the sensory experience. Conversely, lower temperatures can suppress these volatile compounds, resulting in a muted scent. Cooler conditions hinder the evaporation process, causing the aroma to dissipate quickly and leaving a less impactful impression. In this region, the delicate balance of heat, humidity, and scent molecules shapes how rain is perceived. Each drop carries a small yet significant message from the environment, one that is modulated by the thermal conditions at play. Environmental changes and seasonal shifts further complicate this relationship, dictating the nuances of petrichor experienced across different climates. Olfactory fatigue occurs when prolonged exposure to a specific scent diminishes the perception of that odor. In the case of petrichor, the brain adapts to the fragrance of rain-soaked soil and plant oils, leading to a temporary loss of sensitivity to these familiar notes. This adaptation is a natural neurological response, allowing the olfactory system to prioritize new scents over those already encountered. Within moments of experiencing rain, the molecules released into the air blend with the ambient environment, creating an initial burst of freshness. As time passes, receptors become less responsive, and the distinct aroma may fade into the background. This phenomenon can be observed in various natural settings. When rain falls on dry ground, the oils embedded in the soil are released, creating a rich sensory experience. Initial inhalations may evoke a strong emotional response, connecting individuals to memories or sensations associated with rainfall. As exposure continues, the excitement of the scent diminishes. The brain effectively recalibrates, shifting focus to other stimuli in the atmosphere. The intricate interplay between biology and environment highlights the dynamic nature of perception. While some may cherish the scent of rain, its ephemeral quality serves as a reminder of the delicate balance between awareness and adaptation inherent in sensory experiences. Air currents play a crucial role in dispersing the distinct scent that follows rainfall. Wind carries these aromatic compounds, allowing them to travel beyond the immediate vicinity of damp earth. Within this region, the interaction between soil particles and moisture generates a blend of chemical reactions. As rainwater seeps into the ground, it releases oils and organic compounds, including geosmin, known for its earthy aroma. When wind sweeps through, it picks up these volatile molecules and transports them across varying distances. The intensity of this scent can fluctuate greatly depending on wind speed and direction. Gentle breezes may offer a subtle hint of petrichor, while gusts can deliver a more pronounced burst, enveloping the senses in an invigorating embrace of freshness. This phenomenon extends beyond mere olfactory experiences. The composition of air, influenced by temperature and humidity, also affects how these scents are perceived. In warmer conditions, volatile compounds evaporate more readily, enhancing the fragrance experienced by observers. Conversely, cooler temperatures can hinder their release, resulting in a muted scent. Understanding these dynamics reveals the intricate interplay between environmental factors and sensory perception. The relationship between wind and petrichor illustrates not only the complexity of nature, but also the subtle yet profound experiences it offers. Each breath taken in the wake of rainfall becomes a moment of connection to the earth and its rhythms. Comparative studies reveal that the essence of petrichor varies significantly across different regions of the world. In arid environments, the scent emerges with particular intensity after rare rainfalls. The infrequent moisture rejuvenates parched soil, releasing oils and compounds that have accumulated over long dry periods. This phenomenon creates a distinct olfactory signature, rich in earthy tones and hints of vegetation. Conversely, in temperate climates, the response to rainfall is marked by a more subdued release of smells. Here, the interplay between soil microbes and plant roots facilitates the breakdown of organic matter, generating a nuanced aroma that combines hints of damp earth with floral and herbal notes. The overall experience, while pleasant, is less striking than in drier regions. Tropical ecosystems present yet another variation. The thick humidity and abundant vegetation contribute to a complex fragrance profile. Here, the scent is often intermingled with the sweet notes of decaying leaves and the vibrant life of the biosphere. This region's petrichor often evokes feelings of richness and vitality. These regional differences are influenced not only by climate and geography, but also by the types of vegetation and soil composition. Each locale presents a unique olfactory landscape, inviting exploration into the subtle intricacies of this common yet multifaceted phenomenon. Urban environments introduce a distinct variation to the experience of petrichor. The complex interplay between natural elements and human activity creates a unique olfactory signature. In these regions, the smell of rain becomes intertwined with the sense of asphalt, concrete, and industrial emissions. The initial freshness that arises from moisture interacting with soil is often masked by the remnants of pollution. Hydrocarbons released from vehicles coalesce with the earthy aroma, producing a different result. This combination alters the expected experience of rain's scent, introducing a more acrid note that can overshadow the natural fragrance. The presence of heavy metals and particulate matter in urban air adds another layer, contributing to a nuanced and often less pleasant profile. Research indicates that the perception of petrichor in cities can vary significantly based on factors such as wind direction, intensity of rainfall, and even the time of day. In some instances, the mingling of rain with urban pollutants may lead to transient moments of clarity, where the familiar scent of earth briefly breaks through the haze. These urban encounters with Petrichor highlight the adaptability of nature amid human influence. They serve as a reminder of the interconnectedness between the organic and the artificial, illustrating how environments shape sensory experiences in profound ways. Soil moisture plays a pivotal role in determining the concentration of geosmin, the compound responsible for the earthy aroma following rainfall. When moisture levels rise, microbial activity within the soil increases. These microorganisms, particularly actinomycetes, produce geosmin as a metabolic byproduct. Water acts as a catalyst, facilitating these biological processes. In dry conditions, geosmin remains trapped within the soil, its presence undetected. The arrival of rain saturates the ground, releasing this compound into the atmosphere. The chemical structure of geosmin allows it to evaporate easily, dispersing the scent across vast distances. This phenomenon can be detected even at incredibly low concentrations, highlighting the sensitivity of the human olfactory system. The interaction between moisture and geosmin concentration can vary based on soil type, temperature, and the overall ecosystem, which further influences how intensely the aroma is perceived. In sandy soils, for instance, moisture retention is lower compared to clay-rich soils, leading to a different release profile of geosmin. These factors contribute to the distinctive olfactory signature associated with rain, allowing it to evoke memories and emotions linked to the natural world. This relationship between moisture and scent underscores the complexity of environmental interactions, revealing layers of nuances in sensory perception and biological processes. The phenomenon of first rain evokes a distinct olfactory experience, a result of various components released into the atmosphere. Initial rainfall disturbs the soil, releasing organic compounds such as geosmin, which are produced by soil-dwelling bacteria. This compound, detectable by the human nose at exceedingly low concentrations, contributes significantly to the characteristic scent that accompanies the onset of rain. In addition to geosmin, oils secreted by plants during dry periods also play a role. These oils accumulate on surfaces, and when rain arrives, they are aerosolized, further enriching the fragrance. This interplay creates a unique combination of scents that varies from region to region, influenced by local flora and soil composition. The first rain often marks the transition from dry to wet seasons, prompting ecological responses among flora and fauna. This environmental shift can stimulate dormant seeds to germinate, leading to bursts of growth in plant life. Animals, too, respond to this change, often exhibiting heightened activity as they take advantage of the newfound moisture. These interactions highlight the delicate balance of ecosystems, where even the simplest event, such as the arrival of rain, can trigger a cascade of biological responses, revealing the intricate web of life sustained by atmospheric phenomena. The role of algae in aquatic systems is often understated, yet it plays a crucial part in the production of geosmin, a compound responsible for the earthy scent associated with fresh rain. These microorganisms thrive in freshwater environments, where they engage in photosynthesis, contributing to the oxygen levels and nutrient cycling essential for aquatic life. Their metabolic processes result in the release of geosmin into the water, particularly following disturbances such as rainfall. Geosmin is produced by certain species of cyanobacteria and actinobacteria, which proliferate in nutrient-rich waters. Following precipitation events, the disturbance stirs sediments, releasing geosmin into the water column. This compound, even at minute concentrations, can significantly influence the sensory experience of an ecosystem. It serves as a biochemical signal, alerting various organisms to the presence of nutrients and potential food sources. Aquatic systems respond dynamically to these changes, as the influx of geosmin can attract certain fish species, which rely on scent to locate food. Moreover, the compound can impact the overall health of the ecosystem, indicating nutrient levels and potential algal blooms. The presence of geosmin thus reveals deeper connections between rainfall, aquatic microorganisms, and the broader ecological implications of freshwater systems, underscoring the complex interplay of life sustained by atmospheric conditions. Rainwater consists of a complex mixture of components that reflect the interactions between the atmosphere and the environment. Water vapor condenses around particles, forming droplets that collect diverse substances as they fall. These components include minerals, organic matter, and gases from both natural and anthropogenic sources. The chemical composition of rainwater varies significantly based on geographical location and local air quality. In urban areas, for instance, it often contains higher concentrations of nitrogen oxides and sulfur dioxide, which can lead to acid rain. This phenomenon results from the combustion of fossil fuels, where emissions react with atmospheric moisture, forming sulfuric and nitric acids. In contrast, rainwater in pristine regions tends to be less contaminated, revealing a more balanced pH and lower levels of dissolved solids. The presence of trace elements, such as magnesium, calcium, and potassium, influences the nutrient availability for soil and aquatic ecosystems. Dissolved gases, particularly carbon dioxide, interact with rainwater, forming weak carbonic acid, which contributes to the natural weathering of rocks. This process releases essential minerals into the environment, aiding in soil formation and supporting plant life. Variability in rainfall patterns directly influences the prevalence of Petrichor, El Niño, a climatic phenomenon characterized by periodic warming of ocean waters in the central and eastern Pacific. Alters precipitation dynamics across the globe. This warming can lead to intensified rainfall in certain regions, fostering conditions favorable for the release of petrichor. Increased moisture saturates the soil, creating a heightened environment for the microbial activity responsible for the distinct aroma. In contrast, areas experiencing drought conditions may see a decline in petrichor emissions. During such periods, the soil remains dry, inhibiting microbial processes that contribute to the scent. The nuanced interplay between temperature and precipitation during El Niño events can result in significant fluctuations, impacting both the intensity and frequency of petrichor. The relationship between these climatic shifts and the scent of rain serves as an indicator of broader environmental changes. In regions affected by El Niño, the subsequent bursts of rainfall can trigger an olfactory response, connecting ecosystems and their inhabitants to the rhythmic cycles of climate. Understanding this connection enhances insight into the delicate balance of ecosystems, emphasizing how climatic phenomena influence not only weather patterns, but also the sensory experiences tied to the natural world. The subtle yet profound aroma of petrichor encapsulates these intricate relationships within the environment. Geosmin, a compound produced by soil-dwelling microorganisms, plays a crucial role in the phenomenon of petrichor. It is synthesized primarily by actinobacteria during their life cycle, especially in times of stress or nutrient scarcity. This organic compound, with its earthy scent, facilitates communication within ecosystems, signaling the presence of fertile soil and microbial activity. Upon rainfall, droplets disturb the soil, releasing geosmin into the air. The physical process involves tiny bubbles forming in the water, which then burst, ejecting these aromatic compounds into the atmosphere. This release occurs most prominently after dry periods, when the ground has become parched and the concentration of geosmin is heightened. As raindrops collide with the earth, they not only carry water, but also act as a medium for this unique scent to permeate the surrounding air. The wind carries these volatile compounds further, allowing the aroma to reach distant locations, where it can evoke memories and emotions associated with rainfall. The interaction between geosmin and human olfactory receptors triggers a strong sensory response, often evoking nostalgia or pleasure. This link between the microbial world and human perception highlights the essential role geosmin plays in the broader context of ecological balance and atmospheric dynamics, reinforcing the interconnectedness of all living systems. Land use significantly influences the dynamics of petrichor, particularly within agricultural environments. Practices such as crop rotation, soil management, and the application of fertilizers alter the microbial composition of the soil. Changes in microbial activity directly correlate with the production of geosmin, affecting the intensity of its scent during rainfall. The introduction of certain crops may enhance or diminish the presence of specific microbes, leading to variations in the olfactory experience associated with wet earth. Irrigation methods also play a crucial role. Conventional practices often lead to soil compaction and nutrient runoff, which can disrupt the delicate balance of microbial ecosystems. This disruption may result in lower geosmin levels, altering the character of petrichor in affected regions. Conversely, sustainable practices, such as organic farming, promote biodiversity in soil organisms, potentially enriching the scent of rain. The repercussions extend beyond individual farms. Agricultural expansion impacts local hydrology, influencing rainfall patterns and soil moisture levels. These changes can affect the frequency and intensity of rain, further modifying the conditions under which petrichor is released. The intricate relationship between agricultural practices and atmospheric phenomenon highlights the significance of land use in shaping not only ecological systems, but also the sensory experiences that accompany them. This complex interplay invites deeper exploration into sustainable practices that honor both productivity and sensory richness. Petrichor plays a significant role in the delicate balance of ecosystems, influencing both flora and fauna. The scent, a result of oils released from soil-dwelling organisms, interacts with the moisture of rain, creating an olfactory signal that resonates throughout the environment. This aroma not only marks the arrival of precipitation, but also serves as a cue for various species. Certain plants respond to this scent by initiating growth processes, enhancing their reproductive strategies. The release of these oils often coincides with the need for water, ensuring that seedlings and mature plants alike effectively utilize the hydration provided by rainfall. This phenomenon fosters a thriving plant community, which in turn supports diverse animal populations that rely on these plants for food, shelter, and breeding grounds. Fauna, too, is attuned to the nuances of petrichor. Many animals exhibit behaviors aligned with the scent, such as increased foraging or mating activities during and after rain events. The presence of this characteristic aroma may also affect predator-prey dynamics, influencing hunting success and survival rates. And this way, petrichor is not merely a pleasant scent, it is a vital component in the intricate web of life. Its impacts ripple through ecosystems, shaping interactions and fostering resilience among various species. The sensory qualities of crops are intricately influenced by geosmine, a compound released into the air following rainfall. This volatile organic compound is produced by soil-dwelling bacteria, particularly during periods of moisture. Its presence evokes the familiar scent associated with wet earth, enhancing the sensory experience linked to food. The aroma contributes to the flavor profiles of various crops, enriching the connection between the environment and agricultural output. Research indicates that geosmin can affect consumer perceptions of freshness and quality. Vegetables and fruits exhibiting higher concentrations of this compound often elicit stronger positive reactions during sensory evaluations. This phenomenon underscores the importance of atmospheric conditions in cultivating not only the physical attributes of crops, but also their perceived value in markets. Understanding the role of geosmin in food production extends beyond sensory experiences. It informs agricultural practices, emphasizing the need for optimal soil health and moisture management. These practices can enhance the production of crops that resonate with consumers on a sensory level. The evolutionary aspect of this phenomenon reveals a link to survival instincts. This scent, released when raindrops hit dry soil, serves as a signal in nature. It indicates the arrival of precipitation, a crucial event for both flora and fauna. The compounds responsible for this aroma, primarily geosmine and other organic materials, have been fine-tuned over millennia. They attract organisms to areas rich in moisture and potential sustenance. Plants utilize these compounds to draw in pollinators and seed dispersers. The ability to detect such scents can influence animal behavior, leading species to seek out essential resources. This sensory response is not merely a coincidence, but rather a refined adaptation to an environment where resources fluctuate dramatically. In this context, the olfactory receptors of various species have evolved to recognize these chemical signals. In many terrestrial mammals, the perception of petrichor can trigger instinctual behaviors, such as foraging or mating. It is a reminder of the interconnectedness of life, where even the faintest scent can play a pivotal role in the survival of ecosystems. As these chemical signatures waft through the air, they evoke a sense of familiarity and comfort, grounding creatures in their habitats. This primal response to petrichor underscores the importance of scent in the intricate web of life. The distinctive aroma associated with rain is not solely attributed to petrichor. Various compounds released during precipitation significantly contribute to this olfactory experience. When raindrops strike the ground, they displace tiny air bubbles, which rise to the surface and burst. This process releases a mixture of volatile organic compounds into the atmosphere. Among these, geosmin plays a crucial role, produced by soil-dwelling microorganisms. This compound has an earthy scent that is often perceived as comforting. It is particularly prevalent in regions rich in organic material, where microbial activity is heightened. The presence of geosmin can evoke memories and emotions, further enhancing the connection between scent and environment. Another important element in this aromatic profile is the combination of plant oils, which are released during dry periods and absorbed by the soil. When rain arrives, these oils are liberated, adding to the complexity of the fragrance. Additionally, ozone may contribute to the smell of rain, especially after a thunderstorm formed through electrical discharges. Ozone has a sharp, clean scent that often accompanies the first drops of rain. The interaction of these various compounds creates a unique olfactory signature, linking the smell of rain to ecological processes and the intricate relationships within ecosystems. The chemistry of rain deepens the understanding of how this sensory experience shapes human perception and interaction with the natural world. The role of lightning in the atmospheric phenomenon of Petrichor introduces a fascinating interplay between electricity and organic compounds. When lightning strikes, it generates immense heat, exceeding temperatures of approximately 30,000 degrees Fahrenheit. This extreme heat causes nitrogen in the atmosphere to combine with oxygen, forming nitrogen oxides. These compounds subsequently dissolve in rainwater, contributing to the distinct aroma released when rain interacts with dry soil. The interaction between raindrops and the surface of the earth releases volatile organic compounds, particularly from certain bacteria and plant life. These compounds, when mixed with nitrogen oxides, enhance the olfactory signature of Petrichor. The result is a complex bouquet of scents, evoking memories and emotions tied deeply to the natural environment. When lightning occurs during a rain event, it can amplify this sensory experience, producing a sharper, more pronounced aroma. The presence of ozone, often detected after a lightning strike, adds another layer to the olfactory profile. This chemical reaction not only enriches the smell of rain, but also serves as a reminder of the dynamic processes that govern Earth's atmosphere. Understanding these connections between lightning, nitrogen compounds, and the smell of rain reveals the intricate relationships that exist within ecosystems, influencing both the environment and human perception. The influence of scent on human emotions extends beyond mere nostalgia. Petrichor, with its signature earthy aroma following rainfall, has found applications in the field of aromatherapy. This practice harnesses the properties of various natural scents to promote relaxation and overall well-being. By recreating the essence of Petrichor, practitioners aim to induce a calming effect, leveraging the biochemical responses elicited by this familiar fragrance. The components responsible for Petrichor, primarily geosmin and certain oils released from soil-dwelling bacteria, play a crucial role in this process. Their presence in essential oil blends can evoke feelings of tranquility and comfort. These compounds interact with olfactory receptors, triggering responses that can lower stress levels and enhance emotional stability. In therapeutic settings, the gentle diffusion of Petrichor-inspired scents can transform an environment, making it conducive to relaxation and reflection. Spaces infused with these aromas can serve as sanctuaries, promoting mental clarity and reducing anxiety. This subtle approach to wellness emphasizes the relationship between environmental elements and personal health, underscoring the importance of nature in holistic practices. Research into the effects of natural aromas continues to grow, revealing deeper insights into how these scents affect cognition and emotional responses. As understanding expands, so too does the potential for integrating nature's fragrances into everyday life. The allure of petrichor has permeated various facets of popular culture, manifesting in films, music, and literature. Cinematic portrayals often capture the essence of rain-soaked landscapes, evoking nostalgia and the complex emotional responses associated with the scent. Directors frequently employ this olfactory cue as a storytelling element, enhancing the mood of pivotal scenes. The sound of raindrops coupled with the earthy aroma evokes a visceral connection to nature, prompting audiences to reflect on their own experiences of rainfall. Musicians have also drawn inspiration from the distinct scent of rain, incorporating its imagery into lyrics and compositions. This connection between sound and smell enriches the auditory experience, allowing listeners to transport themselves to the serene moments that accompany a fresh rainfall. The delicate balance of wet earth and vibrant life resonates throughout various genres, reflecting a universal appreciation for this natural phenomenon. Visual media, such as photography and paintings, frequently explore the themes surrounding petrichor, capturing the interplay between raindrops and soil. Artists depict the aftermath of a storm, where colors are intensified and life appears rejuvenated. This representation reinforces the significance of rain and its accompanying scent in shaping human emotions and experiences. Through these various mediums, the essence of petrichor continues to inspire, reminding society of the profound connections between nature and the human experience. Concrete alters the interaction between rain and the environment, significantly affecting the olfactory experience of petrichor. In urban areas, the prevalence of hard surfaces prevents water from penetrating the ground, leading to increased runoff. This phenomenon diminishes the natural absorption of moisture into soil, where organic compounds responsible for the earthy scent are typically released. Instead, the moisture collects on these impervious surfaces, creating a distinctly different atmosphere. The composition of urban landscapes introduces additional elements that further influence scent profiles. Oil and other pollutants mix with rainwater, producing a unique aroma that often overshadows the traditional smell of petrichor. These interactions result in a complex olfactory experience characterized by a blend of natural and artificial scents. While some may find this amalgamation intriguing, it detracts from the pure essence of the earth awakening after a rain. Urbanization also modifies the frequency and intensity of rain events, driven by the urban heat island effect. This localized warming leads to altered precipitation patterns, potentially diminishing the occurrences of rainfall that would typically enhance petrichor. The disconnection from the natural rhythms of weather patterns. The role of fungi within soil ecosystems presents a vital component of ecological balance. These organisms operate on a microscopic level, contributing to the decomposition of organic matter. This process facilitates nutrient cycling, allowing essential minerals and compounds to be released back into the environment. Mycorrhizal fungi, in particular, form symbiotic relationships with plant roots. This partnership enhances nutrient uptake, providing plants with increased access to water and vital nutrients such as phosphorus. Fungi also contribute to soil structure. Their mycelium networks bind soil particles together, creating aggregates that improve soil aeration and water retention. This interconnected web supports a diverse array of microorganisms, fostering a thriving ecosystem below the surface. With the degradation of organic matter, these fungi also release geosmin, a compound responsible for the earthy scent that often accompanies rainfall. In the wake of precipitation, the moisture activates dormant fungal spores. The subsequent release of volatile organic compounds adds to the overall fragrance of a rain-soaked landscape. This phenomenon highlights the intricate interplay between soil microorganisms and the atmosphere. In healthy ecosystems, fungi contribute significantly to resilience against environmental changes. Understanding these relationships provides insights into the stability of terrestrial habitats and underscores the importance of maintaining biodiversity within soil systems. The calming scent that emerges after rainfall, known as Petrichor, holds significance beyond mere sensory experience. This phenomenon elicits responses within the human psyche, often associated with relaxation and a sense of well-being. Research indicates that exposure to natural aromas, particularly those released by wet soil and vegetation, can trigger the release of neurotransmitters linked to mood enhancement. In therapeutic settings, the subtle fragrance serves as a natural anchor, promoting mindfulness and grounding individuals in their surroundings. It is frequently utilized in nature therapy, where participants engage in outdoor activities designed to foster mental health. The olfactory cues from rain-soaked earth contribute to a calming atmosphere, enabling individuals to connect with their environment on a deeper level. Such connections are crucial, particularly in urban settings where green spaces may be limited. Incorporating elements of nature, including petrichor, into therapeutic practices can enhance the overall efficacy of mental health interventions. The scent not only stimulates pleasant memories, but also aids in stress reduction and emotional regulation. These therapeutic applications underscore the profound influence of natural elements on psychological well-being. The simple act of recognizing and appreciating the scents in one's environment can facilitate healing and rejuvenation, highlighting the intricate bond between the human experience and the natural world. Microclimates play a crucial role in shaping the sensory experiences associated with rainfall. These localized atmospheric conditions can significantly influence the intensity and character of scents released during precipitation. Variations in temperature, humidity, and vegetation density contribute to distinct olfactory signatures that emerge when rain interacts with the earth. In urban areas, the presence of concrete and asphalt alters the dynamics of moisture retention and evaporation, leading to a different flavor of petrichor compared to more verdant regions. The interaction of rain with soil, rich in organic matter, produces a complex array of volatile compounds. These compounds can be released in diverse concentrations depending on the surrounding flora and fauna. In forested environments, for instance, the dampness enhances the emission of phytoncides, organic compounds that trees release to combat illness. This creates a unique aromatic experience, intertwining the scent of wet earth with that of fresh greenery. Conversely, coastal microclimates introduce saline influences, where the mingling of rain with sea air produces a refreshing, briny scent that evokes memories of the ocean. As conditions shift, the perception of these smells may vary, reflecting the intricate interplay between local ecosystems and atmospheric changes. Each microclimate presents a distinct olfactory experience, underscoring the richness of the natural world. Cultural interpretations of the scent of rain often reflect humanity's deep connection with the earth. Many ancient civilizations revered this aroma as a divine gift, an embodiment of renewal and life. In Mesopotamian traditions, the smell was associated with the goddess of fertility, symbolizing the nourishment of crops and the prosperity that followed the rains. This reverence manifested in rituals and offerings, paying homage to the forces that shaped their agricultural cycles. Verdetani homage to the forces that shaped their agricultural cycles. In the mythologies of South America, rain and its accompanying scent were believed to be the tears of gods, weeping for the well-being of their people. It served as a reminder of the cyclic nature of existence, where destruction and growth coexist. These narratives reinforced the importance of rain, transforming it into a sacred event that united communities in gratitude and reverence. In contrast, certain indigenous cultures view the aroma of rain as a whisper from the earth, a favasal ofta timaix poftadulsme, signifying a moment of connection between the spiritual and the physical realms. The scent heralds not just the coming of precipitation, but also a time for reflection and renewal. Through their unique interpretations, these civilizations instilled a sense of purpose in the phenomenon of rain, allowing the scent to transcend mere chemistry and evolve into a profound symbol of life itself. Mijn huge rosend as my kant merout. Musevios neosi bisingri galaxy sound. Integrating green spaces into cityscapes not only serves aesthetic purposes, but also promotes ecological health. These areas, when designed thoughtfully, can amplify the scent of rain, enriching the olfactory experience associated with precipitations. Soil composition within urban parks plays a crucial role in this process. The presence of organic materials, such as compost and mulch, allows for a more pronounced release of petrichor when rain falls. These components interact with raindrops, facilitating the release of aerosols that carry the familiar scent. Maintaining healthy vegetation also contributes to this phenomenon, as diverse plant species can enhance the overall fragrance during rainfall. Water management practices are equally significant. Implementing permeable surfaces allows rainwater to seep into the ground rather than running off, creating a more pronounced interaction between water and soil. This interaction not only enriches the soil's ability to emit petrichor, but also supports local ecosystems that thrive in urban settings. The careful selection of flora can further enhance this experience. Native plants, adapted to local conditions, can improve resilience and maintain the delicate balance necessary for the subtle release of scents. Urban planners, by prioritizing these aspects, can transform cities into vibrant environments that invite inhabitants to connect with the essence of rain. The loss of natural geosmin production significantly alters the sensory experience associated with rainfall. Deforestation disrupts the ecosystems that are vital for the production of this compound, which is responsible for the earthy aroma that follows a rainstorm. These ecosystems, rich with diverse flora and fauna, contribute to the unique biochemistry of the environment. When trees and vegetation are removed, the soil becomes exposed, diminishing the natural processes that create geosmin. This region, once thriving with life, experiences a shift in its atmospheric chemistry. The absence of plant life limits the organic matter that contributes to soil health. Microbial activity, which is essential for generating geosmin, declines, leading to a reduced presence of this characteristic scent. Consequently, the olfactory signature of rain becomes muted, impacting the overall experience of precipitation. The impact extends beyond mere scent. Ecosystem functions, including carbon storage, water filtration, and habitat provision, are compromised. The disappearance of these services can have cascading effects on local climates and weather patterns. In addition, the emotional and psychological connections that communities have with their environment can weaken as the familiar smell of rain fades into a distant memory. The interplay between deforestation and geosmin production illustrates the intricate balance required to sustain both ecological health and the sensory richness of the world. Laboratory analyses reveal the complexity of Petrichor components, primarily focusing on two key compounds, geosmin and plant oils. Isolated from soil and vegetation, these substances undergo rigorous testing to understand their volatile properties. Geosmin, produced by soil-dwelling bacteria, emits an earthy aroma detectable even at minute concentrations. This distinctive smell becomes particularly prominent following rainfall, when water droplets dislodge geosmin particles, releasing them into the air. Experimental setups often involve controlled environments, where samples are subjected to varied humidity and temperature conditions to simulate rainfall. These parameters influence the volatility of the compounds, affecting their release into the atmosphere. The findings indicate that higher humidity significantly enhances the diffusion of geosmin, intensifying its scent. Meanwhile, the presence of specific plant oils can modify the perceived fragrance, creating a unique olfactory signature associated with different ecosystems. Further studies utilize gas chromatography and mass spectrometry to dissect the compound profiles, allowing researchers to quantify the exact concentrations of geosmin and other contributing factors. This precision provides insights into how variations in soil composition and vegetation types influence petrichor profiles. Understanding these components not only enriches scientific knowledge, but also emphasizes the importance of preserving natural habitats, where the essence of rain continues to evoke emotional connections to the environment. Seasonal changes significantly influence the production and perception of petrichor. During the warmer months, higher temperatures facilitate the evaporation of moisture from the soil. This process enhances the release of oils and compounds from various plants, contributing to a more pronounced scent during rainfall. The interplay between heat and humidity primes the environment, allowing these aromatic elements to be more easily dispersed into the air. In contrast, cooler seasons present a different scenario, with lower temperatures and often increased moisture saturation. The release of these compounds is less pronounced. Rainfall in colder months tends to produce a more subdued version of petrichor, where the scent is present but not as intense. The chemistry of soil also shifts with each season. Microorganisms become more active during warmer periods, breaking down organic materials and releasing additional volatile compounds that enhance the aromatic experience. Regional variations further add to the complexity. In arid regions, the first rain after prolonged dryness brings an overwhelming rush of petrichor, as the dust and soil release long-stored scents. In more temperate climates, the scent may be more consistent, subtly shifting with each seasonal transition. These variations underscore the intricate relationship between rain, temperature, and soil, revealing the nuanced nature of this evocative aroma. Indicators of healthy ecosystems manifest in the very soil that nurtures plant life. This region, enriched by rain and microbial activity, serves as a critical foundation for biodiversity. Healthy soil is teeming with life, hosting billions of microorganisms that interact symbiotically with roots. The presence of certain bacteria and fungi contributes to the unique scents released during rainfall, intertwining the olfactory experience with ecological health. Organic matter within this substrate plays a pivotal role in nutrient retention and water absorption, promoting robust plant growth. The structure of the soil influences its ability to filter water and support various flora and fauna. This complex web of interactions reveals much about the vitality of the environment. Changes in the composition of soil can signal shifts in ecosystem balance. Rainfall acts as a natural catalyst, stimulating the release of volatile compounds produced by soil microorganisms. These compounds not only contribute to the aroma of petrichor, but also indicate the soil's overall health and resilience. Enhanced microbial diversity correlates with greater nutrient cycling and reduced susceptibility to disease, making it a vital indicator for ecologists. Monitoring these subtle changes can provide insights into ecosystem dynamics, guiding conservation efforts and sustainable practices aimed at preserving the delicate balance of life. The nuanced scent that emerges following a rainfall, known as petrichor, plays a significant role in climate regulation. This unique aroma arises from the release of compounds, particularly oils secreted by plants during dry periods, which are then absorbed by soil. When rain arrives, these oils volatilize, filling the air with that characteristic fragrance. The process illustrates an intricate connection between vegetation, soil, and atmospheric conditions. Microbial activity within the soil contributes further to this phenomenon. Specific bacteria, such as those from the genus Streptomyces, produce a compound called geosmin, which also contributes to the scent. The interplay between these microorganisms and the surrounding environment showcases how biological processes can influence atmospheric chemistry. This relationship has implications that extend beyond mere sensory experience. The presence of petrichor can enhance precipitation events, motivating plant growth, and even influencing local weather patterns. In areas where vegetation thrives, increased transpiration leads to higher humidity levels, which can create a feedback loop, fostering additional rain. Understanding petrichor's role in climate regulation not only enriches the comprehension of ecosystem interactions, but also informs broader climate models. This knowledge aids in predicting responses to climatic shifts, ensuring that conservation strategies remain effective in preserving biodiversity amidst changing environmental conditions. Heavy metals present in the soil introduce complexities to the delicate balance of ecosystems. These contaminants originate from various sources, including industrial activities and agricultural practices. When heavy metals accumulate, they disrupt the biochemical processes essential for plant growth and microbial health. This disruption can lead to decreased biodiversity, limiting the ability of ecosystems to adapt and thrive. Geosmin, a compound primarily produced by soil-dwelling bacteria, is often affected by this contamination. The presence of heavy metals can inhibit the growth of these microorganisms, reducing geosmin production. This compound contributes to the earthy scent associated with moist soil, particularly following rainfall. Thus, the reduction in geosmin alters the sensory experience of rain, impacting not only the atmosphere but also the interactions among various species. In regions heavily affected by industrial runoff, the implications extend beyond scent. Altered microbial communities result in diminished soil fertility, affecting plant health and agricultural productivity. Consequently, the presence of heavy metals can initiate a cascade of ecological disturbances, where each link in the chain reacts to the changing environment. Understanding these interactions offers insights into maintaining soil health and ensuring the resilience of ecosystems. Preservation efforts must address the sources of contamination to restore balance and promote the natural processes that sustain life. The intricate workings of olfactory receptors reveal a sophisticated mechanism at play. These specialized proteins reside within the nasal cavity, where they interact with airborne molecules. When these compounds enter the nostrils, they bind to the receptors, triggering a cascade of biochemical signals that recall. In this region, olfactory receptors operate through a combination of specificity and sensitivity. Each receptor responds to a unique set of molecules, allowing for a diverse range of smells to be perceived. Upon activation, signals are transmitted via the olfactory bulb, a structure located at the base of the brain. This area processes the information, distinguishing between differing scents and forming a comprehensive aromatic profile. The experience of petrichor emerges from a blend of organic compounds released from soil and plant materials. Two key components are geosmin and plant oils, which contribute the earthy fragrance following precipitation. The brain then interprets these combined signals, evoking memories and emotions associated with the scent of rain. This complex interplay underscores the profound relationship between the environment and human perception, revealing how interconnected these systems truly are. The science of olfaction thus highlights the delicate balance of life and the importance of maintaining ecological integrity. The relationship between animal behavior and petrichor reveals intricate connections within ecosystems. This scent, released during rainfall, triggers specific responses among various species. Many terrestrial animals exhibit heightened alertness and activity. With the arrival of rain, the distinct aroma signals the presence of moisture, essential for survival and reproduction. Insects, for instance, often emerge from their burrows, responding to the scent of wet earth. This behavior facilitates mating and foraging, contributing to the continuity of their populations. Mammals, too, display a range of reactions. Some may seek shelter, while others venture out to take advantage of newfound resources. The scent acts as a natural cue, guiding their movements and decisions. Birds, particularly, show an affinity for the petrichor scent. During dry spells, the absence of this smell can lead to altered feeding habits and nesting behaviors. The return of rain and the subsequent release of petrichor may prompt migratory species to adjust their routes, impacting ecological dynamics at a broader scale. These behaviors underscore the significance of petrichor beyond mere olfactory pleasure. The interplay between scent and animal responses emphasizes the interconnectedness of life forms within a given environment. Understanding these interactions not only enriches knowledge of ecological systems, but also reinforces the need for their preservation. This recognition of the vital role of soil quality in agricultural practices underscores the significance of petrichor. The aroma released during rainfall signals moisture returning to the earth, revitalizing soil health and promoting microbial activity. This interaction is crucial, as healthy soil serves as a foundational element for sustainable agriculture. Nutrients within the soil become more accessible when moisture penetrates, enabling crops to absorb essential elements like nitrogen and phosphorus. The presence of specific bacteria and fungi, stimulated by the scent of rain, enhances these processes, fostering a rich environment for plant growth. These microorganisms not only help in nutrient cycling, but also improve soil structure, allowing for better water retention and reduced erosion. In regions where farming practices prioritize sustainability, the awareness of petrichor's benefits encourages the implementation of natural farming techniques. Crop rotation, cover crops, and organic amendments enhance soil quality, promoting the emergence of the pleasant aroma following rainfall. This aroma serves as a reminder of the delicate balance required to maintain soil ecosystems. As agricultural practices evolve, the importance of preserving this connection between moisture, soil health, and plant vitality cannot be overstated. The scent of rain thus becomes more than a mere sensory experience. It embodies the intricate relationships that sustain both ecosystems and agricultural productivity. Artistic representations of rain often explore the profound emotional and sensory connections individuals share with this elemental force. Paintings, poetry, and music capture the essence of rainfall, reflecting not only its physical presence but also its impact on human experience. These creations serve as a bridge between the tangible and the intangible, allowing a deeper understanding of rain's role in shaping landscapes and cultures. Visual artists frequently depict rain as a transformative phenomenon, altering the appearance of environments. The way light interacts with droplets creates an ethereal quality, inspiring numerous works that evoke feelings of nostalgia or tranquility. Watercolors and oils often emphasize the fluidity and movement inherent in precipitation, highlighting how it caresses surfaces and enriches the world. Literature, too, derives inspiration from rain, using it as a metaphor for renewal, cleansing, or melancholy. Poets articulate the emotional weight carried by a downpour, inviting readers to reflect on their personal experiences. Through careful word choice and imagery, the written word encapsulates the duality of rain's nurturing and destructive potential. Musicians incorporate the sound of rain into their compositions, creating auditory landscapes that resonate with listeners. The rhythmic patter of falling droplets becomes an essential element, evoking tranquility or introspection. In each medium, rain emerges as a subject that transcends its physical properties, illustrating the profound intersection between art and science. The distinct scent of petrichor, often described as earthy and fresh, plays a vital role in enhancing mindfulness practices. This aroma, released from soil and plants during rainfall, serves as a natural anchor for meditations. The interaction of raindrops with soil releases aromatic compounds, notably geosmin and plant oils, which can evoke a sense of calm and grounding. In this context, the scent of petrichor not only stimulates olfactory receptors, but also promotes a deeper connection to the environment. Engaging with these scents can help individuals become more present in their surroundings. The sound of raindrops, combined with the rich aroma of wet earth, creates a multi-sensory experience that fosters tranquility. Research indicates that exposure to nature's fragrances can reduce stress levels and enhance cognitive functioning. When individuals inhale this refreshing scent, it triggers a physiological response that can diminish anxiety. The soothing nature of petrichor encourages a quieter mind, allowing for a more profound meditative state. This harmonious relationship between scent and mindfulness practices underscores the importance of natural elements in promoting mental well-being. By incorporating the aroma of petrichor into meditation routines, individuals may cultivate not only a heightened sense of awareness, but also a deeper appreciation for the environment surrounding them. Such connections enrich the human experience, transcending mere sensory perception. The conservation of soil plays a crucial role in safeguarding the natural sources of geosmin, the compound responsible for that distinctive earthy aroma following rain. Healthy soil is rich in organic matter, fostering a diverse ecosystem of microorganisms that produce geosmin. These organisms thrive in environments where soil is undisturbed, allowing them to flourish and contribute to the intricate balance of the ecosystem. Erosion, pollution, and improper agricultural practices threaten this delicate equilibrium. When topsoil is lost, the microbial community diminishes, leading to a significant reduction in geosmin production. The result is not merely a change in scent, but also a decline in soil health, impacting plant growth and overall biodiversity in the region. Conservation efforts aim to cultivate sustainable practices that protect this vital resource, ensuring that the soil remains a living entity capable of supporting diverse life forms. Incorporating cover crops, reducing tillage, and employing crop rotation are techniques that enhance soil structure and health. These practices promote the retention of moisture and nutrients, fostering an environment where microbial life can thrive. By prioritizing soil conservation, it becomes possible to preserve the natural sources of geosmin, maintaining the connection between rainfall and its characteristic scent. This relationship underscores the importance of environmental stewardship in sustaining both natural ecosystems and human enjoyment of the world's sensory experiences. The chemistry of Petrichor reveals a complex interplay of organic compounds that contribute to this distinct aroma. Volatile organic compounds, primarily produced by soil-dwelling bacteria, are released into the atmosphere during rainfall. Two key compounds involved in this process are geosmin and plant oils, both integral to the characteristic scent. Geosmin, a byproduct of microbial metabolism, has a notably earthy fragrance, detectable by humans at remarkably low concentrations. This region's soil contains a variety of microorganisms that thrive in damp environments, producing geosmin and other metabolites. The release of these compounds occurs during the impact of raindrops on dry earth, which causes soil particles to aerosolize. These aerosols rise into the air, carrying with them the essence of the ground below. Plant oils also play a significant role in shaping the scent profile of Petrichor. When rain falls, these oils are washed from plant surfaces and interact with the soil's microbial byproducts. The combination yields a rich olfactory experience, often associated with freshness and renewal. Research into the molecular structure of these compounds reveals their unique behavior in the atmosphere. Understanding this chemistry not only enhances appreciation for natural phenomena, but also underscores the delicate balance within ecosystems that produce such meaningful sensory experiences. Cultures across the globe interpret the scent of rain through a unique lens, enriching the experience of Petrichor. In many regions, this aroma evokes nostalgia, often linked to memories and traditions. For instance, in arid landscapes, the onset of rain signifies renewal, invigorating the land and the spirit. It is celebrated in various ceremonies, marking the transition from drought to abundance. Mythos the Free with change in seasons, where the arrival of rain brings forth vibrant life. Communities in these areas often use the scent as a harbinger of spring, symbolizing growth and fertility. The way this scent permeates the air can signal readiness for agricultural endeavors, deeply entwined with local customs and livelihoods. Indigenous populations frequently weave the significance of rain and its smell into their stories and spiritual practices. This connection emphasizes the interdependence between humans and their environment, where the scent of Petrichor becomes a reminder of the Earth's cycles. Urban dwellers may experience this aroma differently, viewing it as a fleeting moment amidst the concrete landscape. In cities, it serves as a reminder of nature's resilience, often stirring feelings of longing for the natural world. The diverse interpretations of Petrichor illustrate its profound impact, transcending geographical boundaries and enriching cultural identities. The connection between natural aromas and public health is significant, with various studies investigating how these scents influence human well-being. This region, where the earthy fragrance of rain mingles with the air, often prompts reflections on the psychological and physiological responses elicited by such scents. The presence of specific compounds, like geosmin, which is produced by soil-dwelling bacteria, contributes to the characteristic aroma that accompanies rainfall. These natural aromas have been found to enhance mood and reduce stress levels within communities. Exposure to the smell of rain can trigger a sense of nostalgia or calmness, fostering a collective identity that strengthens social bonds. The psychological impacts of these scents play a role in promoting mental health, a crucial aspect of public well-being. In urban environments, where concrete and steel dominate, the absence of natural aromas may lead to increased stress and anxiety among inhabitants. Efforts to incorporate green spaces and vegetation not only improve air quality, but also reintroduce these soothing scents to city dwellers. Research indicates that environments enriched with natural fragrances are linked to lower instances of depression and higher overall satisfaction. The scents of the natural world serve as a reminder of the interconnectedness of ecology and human health, revealing deeper implications for community planning and environmental stewardship. Microorganisms and vegetation engage in a mutually beneficial relationship that is fundamental to ecosystem health. These microscopic entities inhabit the soil and rhizosphere, where they interact with plant roots, facilitating essential nutrient uptake. This intricate interplay encourages the growth of diverse plant species, enhancing biodiversity within this region. Fungi, particularly mycorrhizal fungi, form symbiotic associations with plant roots, increasing their access to water and minerals. In return, the plants supply carbohydrates to these fungi, fostering a complex network of exchange. Bacteria also play a significant role, aiding in nitrogen fixation and organic matter decomposition. This dynamic contributes to soil fertility, which sustains plant life and the broader ecosystem. The presence of various microorganisms influences plant health and resilience against pathogens. By producing bioactive compounds, they can deter harmful organisms, creating a more robust community of vegetation. This relationship extends beyond individual species, impacting entire ecosystems. The health of forests, grasslands, and wetlands is intricately tied to the microbial communities that inhabit them. As climate change and human activity threaten these delicate systems, understanding their interactions becomes increasingly urgent. Preserving this relationship is essential for maintaining ecological balance, emphasizing the need for sustainable practices that protect both microorganisms and the vegetation they support. This connection underpins the resilience and adaptability of ecosystems in a changing world. Investigating the role of geosmin in wine production reveals a nuanced interplay between soil microbiology and sensory experience. This compound, produced by certain bacteria in the soil, contributes to the earthy aromas that can enhance the complexity of wine. The presence of geosmin in grapevines, often influenced by environmental factors such as moisture and soil composition, can significantly shape flavor profiles. During the fermentation process, these compounds can be extracted from the grapes, enriching the overall aromatic experience. Wines exhibiting geosmin often evoke a sense of place, reflecting the terroir in which the grapes were cultivated. The subtlety of these flavors requires careful analysis, as prevalence can vary greatly depending on the vineyard's conditions and practices. Winemakers employ various techniques to manage the levels of geosmin in their products. This includes adjustments in irrigation practices, soil amendments, and even the timing of harvest to optimize the grape's aromatic potential. The interaction between the microbiome in the soil and the grapevines creates a delicate balance, leading to unique characteristics in each vintage. The appreciation of these flavors extends beyond mere taste. It invites a deeper understanding of the environmental conditions that shape each bottle. Such insights illuminate the intricate relationships within ecosystems, emphasizing the profound effects that seemingly small compounds can have on human experience. Innovations in petrichor studies are paving the way for a deeper understanding of environmental interactions. Emerging technologies are enabling researchers to analyze the chemical compositions released by soil and vegetation during rain events with unprecedented precision. These advancements are not merely academic, they hold practical implications for agriculture, climate resilience, and urban planning. Sensing technologies such as electronic noses are being developed to capture the myriad scents released from the earth. These devices are capable of distinguishing between various volatile organic compounds, allowing scientists to map out the specific contributions of different plant species and soil types. Such detailed mapping aids in assessing ecosystem health and biodiversity. The integration of artificial intelligence into analytical processes further enhances the interpretation of data. Algorithms process vast datasets, revealing patterns that may have previously gone unnoticed. This capability can inform strategies for sustainable land management, helping to mitigate the impacts of climate change on both natural and human systems. Collaboration between disciplines, including atmospheric science, biology, and data science, fosters a holistic approach to understanding Petrichor. These collective efforts emphasize the interconnectedness of life and the environment. The role of social media has transformed the way individuals share experiences related to Petrichor. Through various platforms, users showcase their encounters with rain and the accompanying scent, creating a digital archive of sensory memories. This phenomenon fosters a community of enthusiasts who appreciate the nuances of rainfall and its olfactory signature. Images of raindrops clinging to leaves and videos of storms rolling in evoke a collective nostalgia, connecting people across continents. The simple act of typing a hashtag can lead to vast networks, where discussions about the science behind the scent emerge alongside personal anecdotes. This exchange of information contributes to a deeper understanding of how environmental conditions influence the intensity of Petrichor. User-generated content often highlights the emotional responses elicited by the smell of rain, reinforcing its significance in cultural contexts. Posts reflect the tranquil moments found in nature, where the arrival of rain can bring a sense of calm and renewal. This growing body of shared experiences helps to preserve the significance of Petrichor in collective memory, as individuals recount their personal connections to this natural phenomenon. Through these platforms, the scent of rain transcends geographical boundaries, fostering appreciation for the complexities of the environment and its many manifestations. The mechanisms of olfaction reveal intricate pathways within the brain, showcasing how air molecules transform into sensory experiences. When rainfall occurs, specific compounds are released from both the soil and plant materials, including geosmin, which is responsible for the earthy aroma. These particles are inhaled, traveling through the nasal cavity, where they bind to olfactory receptors. Each receptor is tuned to respond to distinct chemical structures, initiating a cascade of neural signals. Once activated, signals from these receptors are transmitted to the olfactory bulb, a critical processing center for smell. From there, information is relayed to various regions of the brain, such as the limbic system, which governs emotions and memory. This connection explains the profound emotional responses elicited by the scent of rain, often evoking nostalgia or serenity. Umioia saufen the well starcha or serenity. Arvokan nostalgia or serenity. The complexity of neurobiology and olfaction also includes the influence of genetic factors. Individuals possess varying numbers of olfactory receptor genes, resulting in distinct personal experiences of scents. Environmental conditions can further modify perception, as humidity levels and temperature interact with the chemical signals. Understanding these biological mechanisms not only sheds light on the nature of olfaction, but also highlights the significance of smells like Petrichor, reinforcing the deep connection between sensory experiences and the environment. Weather patterns play a crucial role in the release of geosmin, a compound responsible for the earthy aroma associated with Petrichor. Rainfall, particularly after prolonged dry spells, triggers the release of this volatile compound from soil particles and decaying organic matter. Raindrops create tiny air bubbles that, upon bursting, propel geosmin into the atmosphere. This process is particularly pronounced in arid regions, where dry conditions lead to a higher concentration of soil microbes, contributing to an intensified aroma when moisture is reintroduced. Geosmin is produced by specific bacteria, notably those in the actinobacteria family, which thrive in moist environments. The cycle of wet and dry conditions influences not only the bacteria's activity, but also the biochemical processes within the soil. Following rainfall, an increase in microbial activity further enhances the release of geosmin, creating a feedback loop between precipitation and scent. Weather systems, including front formations and shifts in temperature, also affect the distribution of these smells. Winds can carry the aroma over vast distances, allowing for the scent of freshly dampened earth to permeate an entire region. The interaction between meteorological events and microbial life represents a delicate balance, illustrating the intricate connections within ecosystems that sustain both life and sensory experiences in the natural world. Age alters sensory perception, shaping experiences of familiar scents, like petrichor. Children often respond with heightened enthusiasm, their olfactory receptors still finely tuned to detect subtle nuances. This vibrant response is rooted in a less cluttered sensory landscape, where novelty reigns supreme. As individuals advance in years, the capacity to discern certain smells gradually diminishes. The olfactory bulb, responsible for processing scents, undergoes changes with age, impacting how the rich aroma of damp earth is perceived. This region, central to the experience of petrichor, can become less sensitive, leading to a more muted appreciation of its complexities. It is not merely the physical decline. Psychological factors also contribute. Memories tied to specific scents evolve, altering the emotional resonance of petrichor over time. For older adults, the once invigorating scent may evoke nostalgia, often linking it to specific times or places, rather than prompting the exuberant curiosity seen in youth. The emotional backdrop against which these aromas are experienced shifts, transforming perceptions. Researchers indicates that environmental and social contexts further influence this sensory evolution. Geographic locations and cultural associations create distinct impressions of petrichor, which may vary significantly across generations. Each age group navigates the same atmospheric phenomena, yet experiences it through a uniquely personalized lens. Anani by Muel, a new Petrichor transfer. The intricate study of aroma detection has evolved significantly with the advent of technology. Advanced techniques now enable researchers to identify and quantify the distinct compounds responsible for the scent of rain. These methods include gas chromatography and mass spectrometry, which allow for precise analysis of complex mixtures in the atmosphere. This region, where soil meets moisture, releases a variety of organic compounds. Among them, one notable substance is geosmin, a compound produced by soil-dwelling microbes. When rain disturbs the soil, this compound is aerosolized, contributing to the earthy scent experienced during and after precipitation. Aliciatas nanofacians also involve electronic noses, devices designed to mimic the human olfactory system. These sensors can detect and analyze volatile compounds with remarkable accuracy, providing insights into how atmospheric conditions influence scent release. They are capable of identifying not only geosmin but also other aromatic components, such as terpenes and phenols, which arise from various vegetation. The data gathered through these advanced techniques provides a clearer understanding of how environmental factors affect aroma perception. When combined with meteorological data, these findings may enhance predictive models for rainfall and its sensory impacts on different ecosystems. Such research underscores the interconnectedness of technology and nature, revealing the subtle complexities of atmospheric phenomena. Soil erosion constitutes a significant concern for ecosystems, influencing the balance of nutrients and the health of flora. The scent of rain, identified as petrichor, plays a crucial role in this context. When raindrops collide with dry soil, they displace air, releasing aerosols that carry the signature earthy fragrance. This release indicates the presence of microbial activity, which can be a vital factor in soil health. Healthy soils are often rich in organic matter, supporting a diverse array of plant life. The presence of petrichor can signal that moisture is reintroducing life into these ecosystems. Conversely, areas experiencing excessive erosion may lack the organic compounds necessary to emit this aroma, hinting at diminished soil vitality and increased vulnerability to degradation. This relationship between petrichor and soil erosion emphasizes the importance of maintaining soil integrity. When soil is eroded, the nutrients essential for plant growth are lost, leading to a decline in vegetation. Reduced vegetation, in turn, exacerbates erosion, creating a cycle that can be difficult to reverse. Monitoring the presence or absence of petrichor can serve as an indicator of soil health, guiding conservation efforts. Understanding these dynamics enables better management practices aimed at protecting this vital resource. The importance of understanding this phenomenon extends beyond mere appreciation of its aromatic qualities. This intricate interplay of biology and chemistry reveals how ecosystems respond to environmental shifts. Changes in rainfall patterns, driven by climate change, can significantly influence the production of the compounds responsible for petrichor. Alterations in plant life, soil moisture, and microbial activity directly affect the abundance and diversity of these essential scents. Monitoring the shifts in petrichor can serve as an indicator of ecological health, reflecting the underlying conditions of the atmosphere. In this region, increased frequency of droughts may lead to diminished soil moisture, resulting in less volatile compound release during rainfall events. These changes can signify broader disruptions in local ecosystems, impacting agriculture, biodiversity, and water resources. Recognition of the significance of petrichor encourages proactive engagement with environmental stewardship. Sustainable land management and conservation efforts can mitigate the adverse effects of climate change, preserving not only the aromatic experience of rain, but also the delicate balance of life that depends on it. By fostering a deeper understanding of these intricate relationships, societies can better equip themselves to adapt to a future marked by uncertainty. In the end, the subtle scent of rain becomes emblematic of a more profound connection to the natural world, urging collective responsibility towards its preservation.